right, thank you all so much for coming to Graph Day. We really believe in Web3. We think Web3 is the single most important thing we could be working on right now. But it's not the easiest time for the industry. 2017 was an exciting year for the crypto space, but also a time of irrational exuberance. This exuberance brought in a lot of capital and talent and attention, which are all wonderful things, but it also perpetuated some questionable ideas. 2018 was a sobering year, where the market fell to meet reality. That shock shook a lot of people. It made some people question whether the vision of Web3 was even real or viable. They'd say things like, what are the use cases? Do things really need to be decentralized? What if we're 10 years too early? Well, today I want to blow that narrative out of the water. I want to share what exactly is wrong with the way we build software today. What is Web3 and why is it going to be a significantly better platform, both for users and developers? And what are the steps that we need to take to get there? I want to discuss the concrete problems I think we need to solve, and I'm going to share what the graph is contributing to this effort. So what is wrong with how we build software today? Well, actually, let's first start with the good. We have to remember technology has been moving really fast. We just finished learning how to build software that people actually want to use. Software that's fast, beautiful, and easy to use. Software that's smart. As developers, we were figuring out web technologies, the cloud, mobile, UI frameworks, microservices, DevOps, machine learning, data science. All of this just in the last 15 years. We know how to do this stuff now. Web 2 is mature. So I think we can give ourselves a pat on the back, but now we can take a step back and look at the structure of what we've ended up with. I'm going to give you a spoiler. We made a few oopsies. And there are some things that, with the benefit of hindsight, we can do a lot better now. And this stuff is important. Software is eating the world, and these platforms are the foundation. This is literally the foundation of modern civilization. This is Web 2. It's got a client-server architecture. The client typically talks to the server over a REST API. The server stores its state in a database. The servers can generally scale to meet demand. And there are generally a few other services over here, all of this running in the cloud. There are a few problems. First problem, any of these components can go down either on purpose or on accident. You really have to trust these companies to continue to exist and to operate these servers correctly. If the company goes out of business, gets acquired, if the product gets shut down, or they just decide to change product directions, you, the user, are out of luck. Second problem, these interfaces change all the time. If the database table changes, the server can break. If the server code changes, the REST API can break. Since there's nothing that guarantees that there are no breaking changes, making software updates requires really careful coordination, and this makes software maintenance difficult and costly. Third problem, whoever operates this infrastructure has all the power. If they want to change a record, they can drop into the database. Done. If they want to take your private information and sell it to the highest bidder, done. If they want to wait till a lot of people are using the app and then go in and change the rules on them, that's easy. No one can stop them from doing whatever they want. So these are a lot of problems. And what it boils down to is that you really need to trust these companies. Trust them with your time, trust them with your data, with your money, with your security. And if the last few years have taught us anything, it's that we can't trust these people. Here are just a few headlines from the last few years, and there are hundreds like these. I don't even try most new applications anymore because I don't really want to spend my time and energy on an application that's probably going to get shut down. So if we have to trust these companies, because of the architecture that we're using, we have a really big problem. What all of this trust means is that we end up with monopolies, right? Fewer companies that have more and more power. We get monopolies in verticals like search, social, retail, video, ride sharing, even business apps like sales. Monopolies result in rent-seeking behavior, restricted freedom of choice, and increased prices for consumers. It means that people have less control over how the things in their lives work. Of course, trust is just part of the problem. There's another force at play here: network effects. With both data and liquidity in marketplaces, network effects accrue, further concentrating monopolies. These network effects are a real force. It might as well be physics. Imagine if when we were moving out west as a nation, we just handed out states to the first credible settlers that could erect a few buildings. Here, you take Nevada, you can have Oregon, you take California, in perpetuity for life. That's essentially what we've done here. That's Web 2. So how do these network effects work? Well, if I'm a service provider, then I also get to manage the data. You remember the Web 2 architecture. Since all of that is really complicated to maintain, somebody's got to run that infrastructure, and that somebody's also going to get to control and manage the data. Now, once we've given them that data, their incentive is to create a moat to protect their business. That moat is a data silo. And these silos mean that most software systems don't talk to each other. I mean, I can't even get my Facebook events that I use to track my concerts to sync to my iPhone calendar because Facebook won't let me. And if I miss another Diplo show because of that, we're really going to have problems. So let's take a look at one of these network effects and how they work. LinkedIn was one of the first Web 2 companies, founded in 2002. In the beginning, LinkedIn was a wonderful service, and it was totally worth your time to upload your resume, connect your professional network. But then, as the service grew, and once they had enough users locked in, they switched to the next phase: monetization. This is when they destroy the user experience to drive up profit. And because the switching costs are so high, it can really ratchet this up, and there's nothing we can do. If that wasn't enough, once they drove up monetization, they decided to sell the company to Microsoft. They can do that. Now the new owner has access to all the data. They can change the rules however they want, and there's nothing we can do. Now, LinkedIn is not an exception. Every Web 2 company is LinkedIn. LinkedIn is just a little bit ahead. Another problem with this architecture is that it's a honeypot for hackers. A single lone developer can make a mistake that can expose everybody's private information. These are just a few breaches from the last few years. And I recognize that users don't seem to care enough about privacy to change behavior. It's one of those things that just kind of sneaks up on you, and it's hard to know when to make a change. But we're the engineers. We're responsible for this. We need to fix this. We've been building software that's responsible for more and more parts of our lives on a foundation that was not meant to support that load. Information is moving faster than ever before, but we haven't built the structures to enable large-scale coordination to keep up with that rate of information. If we think about the biggest problems facing humanity today, how to give the 7 billion poorest inhabitants of this planet the same quality of life as in developed nations, how to help every individual reach their full potential, to help them discover their passions, develop their talents, and enable them to do what they love for work. These are all large-scale coordination challenges, challenges that we can solve with software if we could only build high enough without collapsing. So, how are we going to fix all this? We need a platform that gives developers and users guarantees. This platform needs to be built with protocols that have these properties. They need to be open. That means that anybody can use them without having access restricted by gatekeepers. In most cases, this also means market-based pricing. Efficient marketplaces ensure that users are getting a competitive service at the lowest price. As some people might want these protocols to be free, the problem is we can't guarantee these other properties like stability without a way to cover the cost. If we want this infrastructure to be sustainable and we don't want to create perverse incentives, then payment needs to be built in. They need to be secure. In most cases, that means Byzantine fault tolerant or roughly resilient to malicious actors. If we want this infrastructure to be open, then we have to assume that malicious actors are also going to show up, and so we need to be resilient and secure. Stable, no breaking changes. This means that software that works today should continue to run as long as there are users for that software. In order to build software that's stable, it needs to be built on immutable data and deterministic computations, and that turns out to be key. And finally, verifiable. That means even if I don't trust the server, I can check for myself that the service was provided correctly and that the properties I care about were upheld. All of these properties together are required to fix the problems I described. These are the properties that give us a stable foundation. So let's take a look at the Web3 architecture. It starts with a set of decentralized infrastructure protocols. These protocols provide the core building blocks and primitives on top of the hardware. They include things like blockchains and storage networks, anything that requires low-level computation in order to be efficient. Now, current blockchain designs require that computation is replicated on tens of thousands of machines, and that obviously doesn't scale. But we're in the early days of experimenting and exploring this design space. Just this year, we're going to see the release of a new class of protocols in Polkadot and Cosmos. And with these protocols, each application can have its own blockchain, and these blockchains can connect together to benefit from pooled security and interconnectivity. So I think we should expect to see continuing experimentation and much bigger improvements here. On top of the infrastructure protocols, we have what I'm calling logic protocols. These can be built on smart contract platforms, and they encode a set of rules that allow you to solve a coordination challenge amongst participants. A good logic protocol should tackle the smallest piece of functionality that it can so that it can be reused as a modular building block. Anytime you've got a value exchange between a buyer and seller, or consumer and provider, a natural contention arises where the interests of one party may differ from the interests of another. In all of these cases, a logic protocol can encode what a fair exchange would look like. Who's allowed to perform what action? How do you guarantee things like quality of service and dispute resolution? What's the relative value of each contribution, and how should that value flow? And then on top of these logic protocols, you've got the dapps. And a dapp is just an application that's built on top of these Web3 protocols. Now, because all of these protocols are open, they're going to produce a tremendous amount of open data. That data means that a developer can come in and tap into that to build applications that previously would have been out of reach. This data also means that we can have interoperability at the data layer. That means that as a user, I can switch to a different application and continue to have access to all the same data. Every time we take a piece of logic or data and we push it down into the protocol layer, we create a new modular building block that can be leveraged by the next developer and the next. We go from having hundreds of thousands of individual siloed machines, each one that lives and dies with the lifespan of that individual project, to having a giant global machine that persists and is available to all. developers can tap into these networks without fear of them breaking or changing under their feet. Think about how much duplicated work we have across every software company. Setting up infrastructure, databases, managing users and accounts, duplicating features, bootstrapping networks. There's going to be orders of magnitude efficiency gains in this shift. And all of that is only possible because of the guarantees of openness, security, stability, and verifiability that are enforced at every layer in the stack. So this is all really exciting, but how do we get people to actually use this stuff? Where are the users? Well, in a capitalist society, everyone's free to make decisions in their own best interest. And if we want to change user behavior, we have to understand their individual motivations, and we have to give them solutions that are lower friction and more desirable. There are two groups that we need to consider here, developers and users. Let's start with developers. These are the things that developers care about when they're deciding what platform they want to build on. And I think whatever platform solves for these the best is going to win the lion's share of developers. So let's see how we're doing. Let's compare Web 2 to where we're at with Web 3 today and where we might be able to get to as we build more of the infrastructure and the platform matures. So building compelling apps. You can certainly do that on Web 2, but you are also limited to what you can build yourself and what you trust third-party APIs to provide. The dapps on Web 3 are primitive today, and the UX is not great. But once we solve those things, I think we'll be able to build apps that are every bit as compelling, if not more compelling, with Web 3. Ease of development. Web 2 has a couple-decade head start here. The tooling is still really immature for Web 3, so it's hard to build a dApp. But again, I think with Web 3, once we build out the infrastructure, I think it'll be even easier than Web 2 because there's going to be so many more reusable components for developers to reliably stitch together. Maintenance. This is an area that Web 2 struggles because you have to run the infrastructure yourself. Web 3 is already ahead here. Once you deploy a smart contract to Ethereum, you don't need to touch it again. It just runs. Distribution on Web 2 is easy because everyone already has a browser and phone. With Web 3, it's tough. Users have to download a special browser or extension, configure a wallet, go through all of these steps. This is a major point of friction today, and it definitely hinders distribution on Web 3. But we're already seeing where distribution for Web 3 can actually become really compelling. You can see now dApp stores inside of browsers like Coinbase Wallet and Balance, and these discovery experiences can be even better tailored than enclosed platforms like the Apple App Store. Business models for Web 2 are mostly ad-based or subscriptions. With Web 3, I don't think we know what this is going to look like yet for dApps, and I think it's an area we need to focus on. But I am hopeful that because there's payment built into the platforms, and we can do things like micropayments, that we'll be able to come up with some good answers here. And finally, with platform risk, because of the guarantees of the platform, Web 3 is already ahead. So if we look at all of these, Web 3 is certainly behind for developers today, but as we build out more infrastructure and we create more of these modular building blocks that developers can leverage, I think we'll have a platform that's significantly better for developers. And once we do, I think it'll be a no-brainer for every developer to build on Web 3. Now let's take a look at the motivation for users. These are the things that users care about. Let's see how we're doing. For great user experience, Web 2 is already ahead, and this is an area that we need to catch up. So I think we can absolutely do it, and we just need to set the bar high and get there. More features. So this is an area I think Web 3 can really shine. Have you seen any public issue trackers where people can request features for products? Many of these have hundreds or thousands of feature requests. And the problem is a single product team can never hope to build all of the features that users want. Once we open up development so that anyone can come and contribute and get paid, I think we'll see a lot more features getting built. easy setup. This is another place where Web3 can really shine. Because we can have data portability between applications, users will be able to switch to a different app and just pick up right where the last app left off. So think about how powerful it's going to be to give users the freedom to mix and match and try new things and have everything just work with no setup. Marketplaces are already pretty large with Web 2, but because of the one-size-fits-all nature of those apps, a lot of markets are actually underserved. Also, because Web 3 is a fair and neutral platform, I think a lot more people will be able to feel comfortable participating in these marketplaces. And even though I'm sure it's going to take a while, I think that will allow these markets on Web 3 to eventually dwarf Web 2. Price and cost is an interesting thing to consider with Web 3. It's certainly expensive today because the protocols don't scale, and so you have to pay a lot in network fees. Where this ends up, I think it's too early to tell. You have some opposing forces. On the one hand, you have the increased cost of the additional security requirements, and on the other hand, you had the downward price pressure of competitive markets and economies of scale. So for cost, I think we're just going to have to wait and see. And then finally, for stability, because of the guarantees of the platform, Web3 is already ahead. Again, when we look at this, there's some good news and some bad news. The bad news is that we suck. I mean, it's not surprising that we don't have more users, right? But the good news is if we stay focused and we continue building out this infrastructure, the work we're doing now is going to be really important. I really believe that Web3 is going to be better in almost every way. There are about 23 million developers worldwide. Most of these developers do not have the same opportunities that we have here in San Francisco. It's not as easy for them to go out and raise a $2 million seed round or a $10 million Series A. But you know what? They're every bit as capable of writing code. That's the opportunity. There are maybe 100,000 developers at Facebook, Apple, Amazon, Netflix, Google. They may seem like giants now, but they can't compete against 23 million developers, not with a platform that enables large-scale coordination. Consistently, what we've seen is every time we empower creative individuals on a mass scale, innovation explodes. We've seen this with every platform shift, with the PC, the internet, with mobile, and we're going to do it again. It's clear that the platform isn't ready. But if we want to learn about launching platforms, there's a great example that we can look at. The iPhone is arguably the most successful platform of all time. But some of you might remember when it launched, a lot of people thought it would fail. They thought that nobody would want a phone that didn't have a physical keyboard. What are the use cases for this thing, they said. So what did Apple do? Well, they worked and they diligently came up with a way to combine capacitive touch sensors with smart software to detect false touches and intelligently predict what keys you were trying to hit. They got the UX right. And it's very possible that without that one UX feature, the most successful platform of all time could have failed. So I think what this teaches us is that it's really important for us to get the UX right before we stress about metrics like growth. So there are some missing pieces here that we have to build to make this platform complete. We need better and more protocols. It's still impossible to build a lot of the kind of decentralized apps that we would like, so it needs to be possible and easy. Eric is going to be speaking about the design of the live peer protocol as a great example right after this talk. Blockchains are still slow and expensive, but if we can get block times to around 3 seconds, finality to around 6, and transaction cost to under a cent, I think we'll be able to use blockchains for a lot more applications. Alex from NEAR is going to be speaking about the latest in sharding research, later today. UX, we need to fix the funnel. It needs to be easier to get started with dapps. We need to create abstractions to better communicate things like finality to users. And this idea that users should manually approve every transaction, I think, makes sense for large purchases, but is never going to work for state updates in Web3. These are just a few examples. Tara is going to be speaking about fixing dApp UX later today. The browsers need to continue to evolve and build in native support for Web3 protocols. Only the browsers can ensure that users have a great experience while guaranteeing security. We at The Graph would love to work with the browser vendors to help improve these interactions. It's still scary to use Web3 today. We need to invest in security and key management solutions so that users can feel confident using dApps without the fear of loss or theft. I've been talking a lot about open data today, but a lot of data needs to remain private and encrypted. If we can get things like secure multi-party computation, proxy re-encryption, and fully homomorphic encryption to work at scale, that's going to open up a lot of use cases where we need to operate on private data. Smart contract platforms work great, but you are limited to what you can access on-chain. If we can have more efficient bridges between the online and offline world through more and better oracles, that also is going to open up the space of possibilities of what we can build. And finally, if we can make it so that anyone can build a dApp and get paid competitively to do that, that is really going to enable the wave of development that we want to see. So these, I think, are the missing pieces. And I think once we have these built, we'll be able to say that the platform is ready. A lot of these, I think, we can do in the next 12 to 24 months. Some might take 5 years, but once we have these pieces, I think we'll have a platform that's worthy of being and running all of the world's software. I know a lot of you in this room are working on these pieces, and I'm really encouraged by the talent that's being focused on these problems. Okay, so now I want to talk about what The Graph is contributing to this effort. So we at The Graph are building infrastructure. The Graph is a query protocol for getting data off blockchains and storage networks. As soon as you start building an application on a blockchain like Ethereum, you quickly realize that it's really difficult to get the data that you need to your front-end application. Say you're building a digital goods marketplace. The users that want to buy and sell digital goods are probably going to want a way to search and filter for specific kinds of items. Maybe they want to sort to find the most valuable items that are for sale. Traditionally, there have been kind of two ways to try to solve this problem. One, you can either build a centralized proprietary indexing server. The problem is then you lose the guarantees that we care about, like stability and verifiability. The second option is to try to process everything on the client. But depending on how much activity your smart contract has, trying to sync all of that chain data in the client can take minutes to hours to even days. Those were the only two options available until the Graph. Let's take a look at how it works. You start by defining something we call a subgraph. And the subgraph defines what data sources you want to listen to, how you want to transform that data, and what schema you want to use to query that data. Once you've built that subgraph, you deploy it to a graph node, and that node starts subscribing to the underlying data sources. When an event is triggered, it processes that data in a WASM VM, and that allows computations to be fast and deterministic. From there, you can build out arbitrary views on that data and have it indexed for efficient retrieval. And then all of that data is served over a GraphQL API. So what have we been up to? Well, we believe in shipping early and often, and that's the approach that we've taken with this infrastructure. We started by open sourcing our initial graph node implementation July 31st of last year. We've had many projects building on the graph and running their own nodes, and we've been working with them to iterate and really harden the software. Our next phase is going to be releasing our hosted service. We want to make it really easy for any developer to build on the graph without having to run their own infrastructure. And then finally, we're going to be releasing the graph as a decentralized network. We want to make it so anyone can run a graph node to get paid to provide indexing and query processing services to the network. And we want to build in those guarantees around things like stability and verifiability to make sure that users can verify that the data they're getting back is correct. Brandon Ramirez, our co-founder and research lead, is going to be sharing new details about our decentralized network later today. But of course, I wouldn't also be up here if I didn't have something to share. I'm really excited to announce that today we're launching our hosted service and our Graph Explorer. The Graph Explorer is a place that developers can come to find all of the data that's being indexed on the graph and easily pull them into their applications. I'm also excited to announce 7 amazing launch partners. Thank you. Today we're launching with Dharma, Compound, Uniswap, ENS, Origin, Decentraland, and LivePeer. All of these amazing protocols are now available on the graph. So anyone who's building applications and wants to access this data can now do it really easily using GraphQL. These products are going to make it much easier to build on Web3. I'm really excited about these products that we're releasing today, and I want to show it to you now. All right, so this is the Graph Explorer. You can see these subgraphs. These are our featured subgraphs at the top here. If you come down, you can see subgraphs by our community. All of these are in a draft state right now, which means that they're still subject to change. But we have this concept of publishing, at which point we enforce that there are no more breaking changes. Let's take a look at one of these subgraphs. We can look at Compound. So here you can see that it's fully synced. You can see it, what the latest block number is here. This is going to live update as new blocks are mined, and the graph node processes it. You can see this was updated recently, and we support updating subgraphs with 0 downtime deploys. We've indexed just shy of 5,000 entities for the Compound subgraph. If you come down, you can see the playground, where you can see what data is available through the schema, and you can see an example query, which you can hit play and you can query for data. Here you can see the logs, so you can see what events have been triggered and processed by the graph node. And let's take a look at another subgraph. This is Uniswap, which is a decentralized exchange that happens all on chain. And one of the great things about GraphQL is even if you don't know what data you're looking for, with a feature called introspection, you can get a drop-down, and that allows you to just kind of explore around and see what data is available. So let's see how we can look up some information about transactions that have gone through on Uniswap. So even if I don't know what fields exist on these transactions, I can look and I can see, I could grab the block if I want, maybe the event type, and maybe, for example, we can see what the most fees earned on Uniswap transactions have been to the liquidity providers. You can also have parameters for collections, so if I want to do things like pagination, I could grab the first 10. And then if I want to see the most expensive fees that have been paid out, I can do sorting. So I can see order by, see what I can order by. So we want to do fees. And then if we want to see the most expensive ones, we can set the direction to, for example, descending. So if I hit play, there are the most expensive transactions that we've seen processed on Uniswap. So it's just that easy to explore around and find data that's being indexed on the graph and pull it into your applications. So now I want to invite Jannis Pohlmann, our co-founder and engineering lead, up to show you how to deploy and use a subgraph.
Hi. I'm going to stay on this machine. Cool. So you probably wonder, how do I get a subgraph for my smart contracts onto this Explorer, and how do I push it to the hosted service in general? How do I use it in my dApp? And guess what? That's what we're going to do in the next 5 minutes. So the first thing I'm going to do is I'm going to sign in, and this signs me in as Yaniv. I'm on his laptop. And I'm going to go to the dashboard, which allows me to create new subgraphs. And I can see all my organizations, and I have an access token that we will need. First of all, I'm going to create a new subgraph. I'm going to call it counter. It's going to be a very simple subgraph. I'm going to pick a nice image. That should be here. OK, don't go too crazy with this. We don't want to be the next MySpace. OK, so we've got the subgraph created. What I will need for the next steps is an access token. So you can see the subgraph is there on my dashboard. It's not deployed yet. So this is what we're going to do now. So Graph Init is a tool that we provide that allows you to very easily create a new subgraph from an example. And I'm going to use the name that I've used in the Explorer. So it's Yaniv Tal counter is the name of the subgraph. And I'm just going to give it the directory that it should create the subgraph in. And what's nice about this is it creates the subgraph, and it also gives me next steps that I need to run in order to work with the subgraph, deploy it, and so on. So I'm actually going to need the access token again. I'm going to run this command to authenticate with the hosted service. I'm going to pass it my access token. It will store that securely in your system's keychain. And now we're going to do into the counter subgraph. As you can see, it's very similar to like a regular JavaScript or TypeScript project. And first going to run yarn to install all the dependencies that we need for building and deploying this. This should take only a few moments. There we go. And then what we're going to run quickly, I'm going to explain this while we do this, is run yarn codegen. You can see this runs graph codegen, which is another tool that we provide. And what this will do is it will create assembly script, which is a subset of TypeScript that compiles to WebAssembly. Assembly script types for your contract APIs, for your smart contracts, for your events, and also for your subgraph schema, so that you can write your subgraph in a type-safe manner. So now that we've done this, let's switch over to, actually going to do this, open Visual Studio Code, oops. Oh yes, there's a T missing. There we go. Let's take a quick look at what a subgraph actually is, what it contains, how you build one. Starting with the subgraph manifest. If things are too small, let me know, but it looks all right. Cool. The subgraph manifest is where everything comes together, where your schema is referenced, where you can add some metadata, and where for every collection of data that you want to index and be able to query that, you create a data source. In this case, we have a simple data source based on the counter smart contract. It lives on mainnet, and it lives at this address, uses this ABI. And in order to then index data from this particular contract, we define a mapping. In this case, it's an Ethereum events mapping, which will listen to Ethereum events, scan past blocks for those events, and whenever it encounters such an event, it will call an event handler for this, and then that's where you can write your code to create the data that you actually want to query. So here you can see we're using a counter ABI, which is pre-generated from with the Solidity compiler, and we define an event handler for the incremented event. Remember, this is a counter. Whenever this is incremented, it will emit such an event with the new counter value. And the handler we're going to call for this is called handle incremented, and this lives in the mapping, which is an assembly script file. Let's take a quick look at the schema. It's a very simple one. This one has just one data type. So this is essentially the data model for your subgraph. You can define different types. You can define fields on them. You can define relationship fields, derived relationship fields based on values in the different fields of the entities. And these entities you can then create in your mappings. So let's take a look at that mapping. As you can see, we're importing some pre-generated types from the code that's generated from the ABIs, in this case the counter smart contract, and we have the incremented event here. And we also import the counter type from our schema. And this is the event handler that you saw in the mapping, in the subgraph manifest, and it receives that incremented event. We try to load a counter with the ID default counter. There's only one. If that doesn't exist yet, meaning we're incrementing the counter for the first time ever, we're going to create it. We're going to set its counter value from the event, and you can see this is all, it's all auto-completed and type-safe, and then we're going to save that back to the store. So it's basic counter incrementing, and that's basically the gist of what a subgraph is, and you can make it more complex, but we're going to roll with this. So last piece of the puzzle would be to deploy this to the hosted service and look at it in the Graph Explorer. Subgraph, not counter. This is interesting. Oh, it says staging. Okay, so let me fix that. Oops. This is a live demo. Remember? So here we go. This should do it. We didn't, we have a staging cluster, obviously, to test stuff. We didn't create it there. We created it in the production Explorer. So yeah, it's already deployed. And what it does is it builds your mapping into WebAssembly. It uploads all the files that are mentioned in the manifest or used in the subgraph to IPFS. Those hashes might look familiar. Giving you one single hash for the manifest, which then points to all the other hashes, like a unique identifier for that version of the subgraph. And it gives you a URL that you can look at for the live deployment, see it syncing, and also some URLs that you can then use in your dApp. If you're familiar with Apollo, for instance, this URL you could just copy that and use it straight away. So let's take a quick look at this, what this subgraph is doing. You can see it's already synced like 70% of the blocks. I mean, I've created this recently, so there's very few events in there. But it scans all the past blocks up to the current block on the Ethereum mainnet in this case. And as blocks are being added to the chain, it will also scan those for new events that are relevant to our subgraph. Okay, this might take a couple of minutes. Maybe. I mean, it's going pretty fast, but there's probably no data yet. There is. Oh, counter is already at 14, so that's cool. Cool. Okay, so that's the first demo. We've created a subgraph. We've deployed it to the Graph Explorer on the hosted service, and we can look at it. We can run queries. We can see the logs of what has happened. Now let's get data like this into a dApp. The counter is not very interesting, so I've created an example application that uses more interesting data. So we're gonna switch to that. Oh, actually, where was it? So, here. Right, so this is my example dapp. It currently doesn't show anything because I haven't put a query in yet. It's a fairly, let me close this. Don't save. Let's open. Let's open this one. And you can see there is a listings query, but that's currently not really doing anything. So what I'm going to do is I'm going to go to the Graph Explorer. I'm going to go to the origin subgraph because I want to show listings that are on the origin protocol. And I'm going to work on my query a bit. So what I want is I want the status of all the listings. I want the current price. I want the currency that the price is in. I do want all the units that are available, so the number of units currently available. I want the title of each listing and, say, the description. And also, because I want to make it look good, I want to see if I can grab any media files from these listings. So I'm going to, media files are entities again, so I'm going to ask for the ID and the URL. And let's say I want the first 50, and I want to query the most expensive one, ignoring the currency. So similar to what Yaniv just did, order by, say, price, order direction descending. Let's run that quickly. There we go, we have listings. And let's put exactly this query in to our app. And now I hope I can switch over to that dapp fast enough, maybe. There we go, it's already refreshed, too fast for me to switch. And these are the 50 most expensive listings on Origin. Cool, I think that's it. I'll hand it back to Yaniv.
So the original vision for the graph was really simple. We wanted to create this experience where developers could come and, with just a few keystrokes, find all of the data that they want to pull into their dapps. We're launching our hosted service today with 7 great protocols. And we're going to keep adding more data and more data. And when we launch a decentralized network, all of this data is going to be available on a network that's open, stable, secure, and verifiable. Together, we can build a solid foundation for software, a new platform that allows us to build farther and higher than ever before. And when we do, it will change how humans cooperate and organize and create economic opportunity for everyone in this global connected world. On a personal note, this is the most exciting ride that I could hope to be on. And I'm so thankful that enough people have gotten the call that we can make this happen. So we've got a really great day planned for you today. Thank you so much for coming. Thank you very much.